Cathodic Protection Network online training course, module 01, page 3. A corrosion control engineer must constantly be aware of the electrical energy that is around us all the time and that drives the corrosion process and affects everything we do in our everyday lives. I'm reading my own script here, you'll have to forgive me. Pipeliners are out of sight and pipelines are out of sight and out of mind. So little attention is given to the fact that metal dissolves in some solutions and gives off electrical energy. It is left to the corrosion engineers to worry about such things until a pipeline fails, causing loss of life, environmental damage and massive financial consequences. Consultants are then asked why the pipeline failed, and the debate about the criterion for cathodic protection receives attention for a little while. Ship and boat owners are constantly aware of the damage caused by corrosion, and consequently metal boats are protected by cathodic protection. They have lumps of metal attached to the hulls for this purpose. These lumps of metal dissolve in the water and give off electricity which prevents the hull from corroding. Sir Humphrey Davy first introduced this system by attaching pig iron to the copper-clad hulls of ships. This was one of the first things I was told when I started as a corrosion control technician in the 1970s. I was given a piece of copper in a plastic tube full of saturated solution of copper-sulphate, and I was told that this is half of a cell and the pipeline was the other half. This is a lie. There are many corrosion cells on every section of pipeline and steel structures to which we connect the common pole of a metering system. So it is only in a laboratory that this item can possibly be half of anything. It is also untrue because what is described by Nernst is a half-cell reaction and not a physical item. Calling this item a half-cell is like calling a thought a brain. A half-cell reaction is software, and you cannot put it into a piece of copper in a saturated solution of copper sulphate, no matter how you try. To say that a ground contact electrode scans an area of pipeline is also a lie. It cannot scan anything. To say that you can calibrate a half cell is rubbish. There is no way to calibrate it. We clean a copper-sulphate electrode and replace the solution. We can compare the potential of this item with another such electrode, but even this is not calibration. But to do this is cheap and easy to do it yourself. We can make a copper-sulphate electrode ourselves. The materials are readily available in ordinary shops because they all have domestic uses. You can buy copper-sulphate online if you can't get it in your local shops. We can carry out tests to see the variations that we can achieve in the voltage that we can measure between each electrode. Right, here are two copper-sulphate ground contact electrodes that I made myself. They are pieces of copper in a saturated solution of copper sulphate. I've put them in tubes. This is a tube that I bought in a fancy dress shop. It was full of bubble liquid or something like that. This is also a suitable tube, plastic tube. And if you take some wire out of its insulation wrap, you have copper that you can put into a saturated solution. Oh, that's not very saturated. Let me get one that looks more the part. There we go. You can put this copper into a tube of saturated solution of copper sulphate. Now, what you can see poking out of the other end is not copper, just in case you were worried. It is a toothpick, which is porous and which can contact the electrolyte. And this little gadget works as well as any other so-called half cell, both on the bench experimentally and also in the field on real pipelines.